So here's a problem. Say we have a line segment of length 2, and we have to place it so that one of its endpoints is on the x-axis and the other is on the y-axis. If we mark all the places its midpoint can be, what shape do the marks trace? We did this in another video through the concrete method of just drawing it out and found out that the shape would be a circle. Today, let's think more about why it has to be a circle from a geometric point of view. The inspiration for this first proof comes from a different way of trapping the line segment within the right angle. If one endpoint is fixed at the origin and the other is free to swing across the first quadrant, then the midpoint traces out the same quarter circle as we've seen in the original problem. Why are they the same? If we match up the cases that place the midpoint in the same position, we see the two line segments cross, like this. Since they intersect at their midpoints, we know that all 4 of these legs of the cross are the same length. We can then draw a rectangle by connecting the 4 corners of the cross. In fact, we can draw such a rectangle for any line segment lodged between the axes, and the added diagonal of the rectangle would always meet the line segment at the midpoint and extend to the origin. Therefore, the midpoint is always half the line segment's length away from the origin, i.e., it's on a unit circle centered at the origin. I said this was the first proof earlier, didn't I? Because there's a second proof I want to show you as well. And its inspirations come from this problem about a semicircle, its tangents, and the extensions of the inscribed angle on the diameter. Instead of considering the midpoint a point on the circle about the origin, like in the first proof, we can also consider it the center of a circle. If the line segment is the diameter, then the fact that its endpoints connect to a right angle at the origin means that the origin must be on the circle. That makes the origin 1 unit away from the midpoint. Again, we can draw a circle that passes through the origin using any line segment lodged between the 2 axes this way. Since the line segments are all 2 units long, the radius of the circles are all 1. Therefore, all midpoints are 1 unit away from the origin. Phew, math makes sense again. Now the question becomes if we can use either one of these ideas to show that the midpoint traces out an ellipse instead, when we tilt the axes to meet at a different angle, as we've seen in the previous video by drawing them. Let me know what you think in the comments below, and until next time, stay curious.